Oxidada, ela entrou boa aqui, oxidou com o tempo e ele voltou.
Hello, everyone. Welcome. Thank you all for waiting patiently for us to get started here on the hour. I just wanted to mention we're going to wait a few minutes before we get started, but we always like to start things off with a bit of an icebreaker exercise, something to get us thinking about the topic to get started. So we would love for you to utilize the Menti. You can either scan it with a phone on the slide. You can also go to menti.com and use the code that is on the slide, or we also will have it available for you in the chat to link to directly. And what we'd like to know from you is what kinds of energy saving opportunities are you currently pursuing? So go ahead and fill out the Menti. We're going to get to it and unpack a little bit about what you're all working on right now. And for those who just joined, welcome. We'll wait maybe about 30 seconds to a minute before we kind of get started here while folks are joining us from their previous meetings and work. But feel free to utilize the Menti and answer the question. We're super curious to know what kinds of energy saving opportunities are you currently pursuing? This is right on topic with what we're going to be talking about today. Great. See some folks. I also just want to mention, of course, you're not obligated to have your cameras on, but we do love to see who we're talking to. So it is highly recommended if you feel comfortable and you're in a space where you can turn your camera on. We love that. It really helps with engagement. Oh, I see some coming on. Thank you. So feel free to turn them on, and maybe even when we get into the Q&A, it's really great to see who's asking those questions. Perfect. All right, so you still have a bit of an opportunity to do the Menti if you're just joining us, so feel free to plug in your responses to the Menti as we get kicked off here. We're going to hear a word first off before we get started from David Nsa from the IESO. He's here to give us a bit of an update. So David, I'm going to pass it over to you.
Thank you, Amanda. And it's a pleasure to be here with all of you. My name is David Insa. I'm an advisor within the business programs at the IESO, specifically focused on engaging our market allies and trade partners in the forest products industry. I'm really, like I said, I'm excited to be a part of the discussion, and I'd like to leave us with two things. We have programs to support businesses and communities in line with our mandate to assure reliable electricity and affordable power across Ontario. So there's opportunities and programs we have available for you, and these programs can incentivize some of your capital projects, coaching, and training for your organizations. I'll be in the chat, so if you'd like to reach out or would like to schedule a chat with me, feel free to reach out. But altogether, thank you so much, and looking forward to this discussion. Over to you, Amanda.
Thank you so much, David. We're super happy to have you here joining us today. Excellent. So we are here today all together. What are we doing? We're going to be talking about energy saving opportunities in the forestry sector, and I'm really excited that we have some subject matter experts. We're going to do this kind of in a format of a discussion, kind of a moderated discussion with our experts, Shannon from Stand Consulting, as well as Nick is joining us from Goldfin. And I also want to give a quick shout out to Finnan, who's joining us as a producer. My name's Amanda. I'm an energy skills coach, so I'm going to be sort of helping to moderate this discussion and hopefully taking some great questions from you all as we kind of wrap up the moderated part of it. I do want to mention that you should utilize the chat. So even during our moderated discussion before we get to the Q&A, feel free to ask questions, especially if they're about the topics that we're talking about. about. If you have questions that are kind of outside the topics that we're talking about, you can put them in the Q&A, and we're going to come back to them in the last 15 minutes of the session. And as I mentioned, feel free to keep your camera on. You can like comments and posts, be engaged. This is all about kind of a workshop and getting the most out of it for yourselves. I want to mention it is a workshop. We do have a participant workbook that we've created that will help you track information that you're learning about today. It also has some really cool key takeaways that you can reference after the session. So it's a great resource, and I highly recommend downloading it from the link that's in the chat and following along as we go. So today's objective is all about helping find opportunities within the forestry sector. So we're going to be identifying energy saving opportunities. We're going to learn about some common opportunities that are specific to the forestry products sector, and we're going to answer your questions. So I wanted to go back to that original Menti and see what type of opportunities folks are pursuing. Was there any challenge with the Menti, guys? Just want to check in if folks had enough time to click the link. If you missed it, feel free. I think Finan has put it in the chat again, so feel free to fill it out. I see some answers coming through. Thanks all. So we have one person that is doing some low-hanging fruit, but moving on to more challenging projects. And then someone else, it looks like, is pursuing lots of low-hanging fruit, so not quite getting into some of those more challenging projects. A couple people working on low-hanging fruit opportunities, and then we have one person that is focused on more challenging projects. So I think we'll have a little bit of something for everyone, for those folks who are still in the stage where they're tackling kind of those easy opportunities, quick wins, as well as an opportunity to ask questions, maybe about some of those more challenging projects that you're working on. I think we have a pretty good balance. I hope our SMEs are noting that, what types of projects folks are working on, because we'll be getting questions likely related to a lot of those. Excellent. So our next question, we're going to do another really quick little Menti here. Our next question is, what do you currently do to find opportunities? So you can use the same link for the Menti. It should pop up again. I want to know, what are you already doing to find energy saving opportunities within your operations, within your facilities? So go ahead and rate these different modes of finding opportunities. I'm just curious to see what's already kind of happening within your operations. Oh, I'm super excited to see that some of you are having energy hunts and energy audits, regularly scheduled energy hunts. That's great as well. Some vendor recommendations, employee suggestions, and a big one, it looks like most popular is reviewing energy and equipment data. Oh, it looks like energy audits came out on top. So most of you are using energy audits and reviewing the data that you have to currently find opportunities. So I want to talk a little bit about different strategies to find opportunities, kind of a three-pronged approach to identifying opportunities. So these three approaches we have here are approaches to identify opportunities, and they can loosely be grouped into data analysis, site investigation, and also employee strategies. So data analysis is all about understanding your equipment and processes to see where waste is occurring. And then we have site investigations, those energy hunts that a lot of you are already doing, which is where you're going out and looking at how your facility, your processes, and equipment are operating. And then finally, employee strategies. It seemed like some of you are taking employee suggestions. Those are really all about getting staff engaged and really supporting your efforts. And we really like to promote using some of all three. That's the ideal situation. And it's if you're not using a little bit of all three, you might not be getting the complete understanding of your opportunities. So not using data means relying on assumptions that might not be accurate, right? And then without on-the-ground site investigations, you won't have a good understanding of what is actually happening in reality and why. And then without employee strategies, you might miss key insights or really limit your ability to implement solutions. So we highly recommend taking some of all three of these in your approach. So on page 2 of that workbook that I already mentioned, there is a checklist for you to indicate which of these strategies you're currently using and a space to write down which you'd like to start implementing. Okay, so I'd recommend just kind of going there, making a note of it. There may be some gaps in your approach to how you're finding energy waste. So for this next section, we're going to explore different types of energy waste to really help you picture what it looks like and think about where it might be occurring within your operations. So as we go through this next section, please follow along on page 3 of your workbook and write in the space provided. You can write down where you think these types of waste that I'm talking about might be occurring in your facilities to kind of help start getting you thinking about areas that you might have missed. So I'm going to go quickly through some of these. It's not necessarily new information for everyone. It might be a bit of a refresher. Here we have 9 types of energy waste, and I'll describe each of these briefly, but remember the purpose of these is not to create sort of strict definitions to fit opportunities into. They're really meant to help illustrate what waste can look like, to help you think about where opportunities might occur and to recognize waste when you see it. So the first one I'm going to talk a bit about is that unnecessary running or idling. And it's pretty self-explanatory. It's equipment running when it doesn't need to be, right? So the trick with this one is sometimes thinking about what needs to be actually means. You know, ovens may need to warm up before production starts, but do they need to warm up hours before production starts, right? So those are the kinds of questions we want to ask. Suboptimal efficiency refers to any equipment or system that isn't operating as efficiently as it could. So it could be, could the efficiency be improved by upgrading the equipment or maybe changing sequencing or other operating parameters? And then misapplication, it really means using wasteful equipment or processes when you have a more efficient option available. So using compressed air to clean off clothing, maybe, you know, it's a particularly sort of egregious and maybe not safe example, but how many of you have seen people use a high volume hose to push some product across the floor or into a drain instead of just, you know, grabbing a broom? So this is the kind of misapplication that we might be talking about here. So leaks are another pretty obvious one to imagine, and even if sometimes they aren't the easiest to spot, right? These can occur with water, it can occur with compressed air, heating and cooling or other systems like the ones we have up on the slide here. Seals and traps are a big one in this sector, right? They're more specific for you. And then malfunctions may seem like an easy one to spot, but there are likely some issues that just never get around to being fixed, or things like, you know, actuators that people assume are working and being controlled, but never actually check to make sure they're working properly. So those are some of the gaps we're talking about with malfunctions. And underutilization can be a big one. It can include kilns, you know, production lines or other processes working at part capacity. And we're going to get into more of this in detail as well when we're hearing from Shannon and Nick very soon. So friction loss can happen in moving parts like motors or conveyors. A good tip is that if it's noisy, it's lossy, loosey. And if it's noisy, it's probably there's an opportunity for efficiency. But this can also include buildup within pipes that introduces friction, right, by constricting the pipe diameter. So that's something to look for. And then system imbalance can happen when there's a mismatch between what is required and what is being provided by a system. So for instance, if you're simultaneously heating and cooling a space, you have a system imbalance there. Okay, so I wanted to touch quickly before we hear from Nick and Shannon on traditional lean waste. And this refers to, inefficient production and can include, defects or lost product, excess processing, overproduction, unnecessary motion, right? Moving things that shouldn't be moved, moving them back and forth, transportation, inventory, or unnecessary waiting time. So in forestry, some quick examples might include a sub-optimized woodyard management, which can really impact energy consumption in the mill. And also suboptimal fiber, flake, or lumber recovery rates. An example sort of having a lack of operator training resulting in high lumber reject rates to the chipper. So these are some specific examples of traditional lean waste that are important to look out for. So I want to do another quick little survey, get some thoughts. Do you have any sense from within your own operations where lean waste might be occurring for you? Or where have you found it occurring already? Maybe you've already solved it. We want to hear about where that's showing up for you or where you think it could be happening, but maybe you haven't had a chance to fully investigate. So please do click on the Menti link and fill and type in some ideas of where that might be occurring. It also helps give our subject matter experts a really good idea of what to focus on as they're talking through some of the questions we have for them. And I'll give you guys a moment. I know it takes time to kind of think through some of these things as well.
That's a good
It's
one,
like,
though. We could just leave
yeah,
that on.
yeah, that's just right in the middle. That's all we need to know. No. I hope you all have like super lean production, no waste happening. Or maybe you're not quite sure yet, and we're gonna get some ideas from our chats. So the chipper and off-grade production, those are two that have come through. Two good examples, I think, and probably have some good stuff to talk about with those. Over drying, yeah, absolutely. During changeover, so kind of shift changeover or maybe product changeover, things like that. Yeah, absolutely. Idle time for sure. So those down times that maybe are a little bit longer than we would like them to be, where things are still running. Absolutely. Great. These are some good examples and pretty common ones, I think, as well. Equipment efficiency. That preheating. Oh, yeah, preheating. Absolutely. Great. Thank you all. Just needed a little time to think about it there. Great. Thanks for sharing. I think we're going to get into talking about some solutions to at least some of these ones. And so I think we have one more kind of Menti before we're going through. I'm curious, what are your 3 largest energy users in your system? So we're going to start talking next a little bit about some of the most common significant energy users within your operations. And it looks like we may have had some folks putting in this in already. I don't know if we've got, I think we have more answers here than we have people, so I'm not sure it's going
You can
to
pick
compress.
3, so.
Yeah. Oh, that's what it is. Sorry, Nick. Thank you for that reminder. So folks have significant energy use of compressed air. That's interesting. Drying, for sure, that makes sense. Some folks with refining as significant energy users. Some air handling, pumping. I'm surprised we don't have anyone voting for kilns. I guess maybe they're not the most significant. I would
Depends who
have
we've
to
got
defer to
here,
the experts. Yeah,
whether we've got sawmills, like
got
lumber
it.
mills represented or
Yeah.
not. Also, you might just refer to it as drying, I suppose.
Ah, very true. Yeah. It could be captured in the drawing. Excellent. Okay. So it sounds like some of you have put in some thought already into what your significant energy users are. I'm going to talk a bit more about managing your significant energy users. So in forestry, obviously, you can have some very energy intensive processes that you want to make sure are operating efficiently. And just a note on page 4 of your workbook, there is a list of common SEUs for your sector and a space for you to write down those top 3 that you identified in the Menti survey. There's also a brief checklist of steps you can take to ensure your largest energy users are operating efficiently. Just maybe as a show of hands, and you can use the little raise hand function, how many people are able to sort of check off all those components of managing SEU? So are you kind of doing it all to manage your SEUs, or are there some opportunities? Anyone able to check off all those components on your workbook? Just
Lots of
curious.
letters on this slide, Mandy. Got
Well,
SEUs and KPIs and SOPs, all the good
oh,
initials.
all the best acronyms there, I think. Yeah, absolutely. Yeah. So it seems like there's opportunity here as far as managing those components. Managing SEUs is a big component of the ISO 50001. So if you're interested in learning more about how to manage your SEUs, I do suggest following the links in the workbook to some relevant sections within the 50001 Ready dashboard. And Save on Energy will also be adding an online video course on managing SEUs. If it's not already there, it's coming to their training site later this year. So there's lots of information on those and more information also in the workbook, as I mentioned. So I am not going to waste any more time talking your ear off about some of these basic kind of background stuff, setting the stage for this. We're going to get right into hearing from Shannon and Nick about some specific opportunities. So I want to give Shannon and Nick a chance to introduce themselves. Maybe we can start with Shannon. If you want to give a quick kind of background on your experience and why we have you here today, it would be wonderful to hear from you.
Thank you, Amanda. Yeah, good afternoon. I am Shannon Fair. I'm a professional chemical engineer and a principal consultant at Stand Consulting. I've worked primarily in pulp and paper and chemical plants since about the year 2000 in both Ontario and in Alberta. My experience spans the industry from craft and TMP market pulp production to newsprint and uncoated free sheet manufacturers. So the answers I give to some of the questions today will obviously be from the perspective of a pulp and paper manufacturer. My work in those industries has primarily been in process and project engineering, including the construction of a bioenergy facility. I've done quite a bit of regulatory management on the energy and carbon and environment sides and energy policy advocacy in Alberta. I'm very happy to contribute to the conversation today.
Thank you, Shannon. We're super happy to have you here as well. And Nick, yeah, I'd love for you to introduce yourself. Since we've got two SMEs, we're very lucky today.
Correct. Hi, my name is Nick DL. I'm a professional engineer, certified energy manager, and managing partner at Goldfin Consulting. I've worked in energy management in the forestry industry or forestry product sector since my first job at BC Hydro many years ago. Here I led their pumps and other motor systems optimizations initiative, which took me to most of the pulp and paper mills in British Columbia at the time. Although I'm happy to say I know enough to know I'm not an expert in pulp and paper, and that's why we've got Shannon here today. In more recent years, I've worked with several lumber mills and panel production mills across Canada and the United States. I've provided coaching and technical support to help identify, investigate, and implement several projects from operational changes to capital and incentive projects for lighting, fans, pumps, and compressed air systems. I'm really looking forward to the excuse me, to the discussion today.
Excellent. Thank you, Nick. We are looking forward to it as well. So I just want to mention we're going to have sort of a moderated, free-flowing question. We've prepared some questions for Shannon and Nick to really dig into where the opportunities lie within their two areas of specialty. But I did want to mention again that you can use the chat function if you have any comments or questions during the discussion. We will try to fit it in if it makes sense during the chat, or we might leave it until the Q&A. So we will moderate that accordingly. So I'm gonna, I think, start off with a question first for you both, and maybe we'll have Nick answer first. But I'm wondering, from your perspective, Nick, what makes managing energy use in the forestry subsector unique or particularly, challenging, I would say. Any thoughts on that?
Yeah, I think focusing on the latter, the challenge, in my years working with industrial energy efficiency, I think it's been evident just how lean the forestry mills are running. And, I think this is fairly true across industries, but I think it's, more true in forestry that they've been running lean and at this level of resourcing and resources for a long time. So I think today's topic is really great, talking about savings opportunities, but I think it's also important to remember that, part of the challenge is just making these opportunities someone's priority over or just, keeping the mill running. So we've got some strategies, thoughts on how we can go about this that we'll get into in the discussion.
Excellent. Yeah, it seemed like we kind of heard that in that survey, the Menti survey, about the lean, that it seems folks are already running quite lean. There's not as many opportunities in that. Yeah. Shannon, I guess same question to you. What makes it unique or challenging from your perspective in your area?
I have a few points on that. I think there's a lot of challenges that face us. One of them is pulp and paper in Canada is an established industry, and many of the facilities we operate are older vintage, which lends itself to not being particularly energy efficient. I think sometimes it can be a scapegoat, but we have to consider the Canadian climate if we consider or compare ourselves to, for example, our U.S. counterparts, especially in the South. The truth about the forestry industry also is it's incredibly capital intensive. New investment and upgrades are costly, and investing in Canada is more expensive than in some other jurisdictions. And for pulp and paper specifically, I think high water consumption rates are both a challenge and an opportunity. Yeah.
Yeah, excellent. So some things that are within our control and some things that maybe aren't as much in our control, especially in Ontario and especially in Northern Ontario and places like that. So yeah, I think those are really good points to make. But there definitely will be stuff that that is in our control that we can identify here. So thank you for those great insights from both of you. So I have another question, and maybe we'll go back to Nick for this one to start. But what are, I guess, common misconceptions about where the biggest energy savings can be found in forestry operations? Like, what are people kind of maybe misunderstanding or assuming that there's savings where there might not be, or vice versa? What do you think, Nick, on that?
Yeah, I think where I would start there, and it might differ depending where you are at in your energy management journey. We saw in one of the Menti polls, there's those that are looking for low-hanging fruit versus those that are into challenging projects. But I think in either case, there can be this misconception that big savings require big investments, which doesn't mean that big investments can't achieve big savings, but I have seen time and again, there are big opportunities of a more operational nature. So Shannon already mentioned the aging mills, and yeah, what I've seen, what in across industries in older mills, facilities that have been repurposed, changed over time, that and they're doing things they were never originally designed for. So that unless all along the way, we were carefully engineering and making energy efficiency decisions about how those changes were implemented, you're likely to see inefficiencies as a consequence. And so some of that is hard to change, but a lot of it require, if you've got a team that's empowered and looking to make some operational changes and maybe some small investments, quite a bit can be accomplished.
Yeah, that's interesting. Yeah, sounds like in some cases some of the inefficiency is a little bit like grandfathered in, or there's some lock-in happening with some of that, but still some opportunity to get investment and to
Some of
find
both, I
wins.
guess.
Yeah,
It's
some of
like
both. Yeah.
my to distill the point, it's like these changes often lead to waste. And so that's
Hmm.
doing things that systems doing things they weren't initially intended to. And if no one's looked for it before, it's probably sitting there.
Excellent. Yeah. So same question, Shannon. What, from your perspective, some common, misconceptions about where the biggest energy savings can be found?
Well, I think we are all really focused on production lines. We're in the business to produce forestry products, right? But one of the places I think where energy savings are an opportunity are inefficiencies in non-production equipment. So
Excellent.
supporting equipment in your facility that might come out when you look at your significant energy users. For example, in the summertime, chiller load could be very high. And we use a lot of water. So you have to treat it not only on the way in, you have to pump it around your facility, but then you have to treat it and aerate it on the discharge side. And so there's a couple of slides here. There's some real opportunity, I think, if you wouldn't mind going back to chilling just for a second.
Yeah,
Yeah, thank you.
absolutely. I jumped
So
ahead.
yeah, chilling water is for space cooling, but it can also be for process cooling. And if you're not seeing a variation in your chilling load with different process changes, you might have opportunities there. Also, the forestry industry, we work in an environment that's highly fouling. And so air exchangers or air dumps on our chilling equipment or cooling equipment, it can be very challenging to operate. So low efficiency for the energy you're putting in. You don't get very much cold water out. So one of the ways to avoid that is simply by speccing all of your heat exchangers in your process for your raw water temperature. And then you can focus your chilling on space cooling. That's an example of a place where we can save quite a bit of energy in the order of megawatts, depending on your facility. And then the next slide is effluent aeration. Aerators and compressed air use a tremendous amount of electricity, and there are some simple things we can do to make sure we're optimizing that, like installing controls like dissolved oxygen controls on aeration to make sure we're modulating the amount of air we're putting in based on the way our facilities are operating. And if you're again not seeing a change in the load of your effluent treatment and your blowers with production, there's certainly an opportunity to certainly an opportunity there.
Excellent. Oh, thank you, Shannon, for those very specific examples from a non-production perspective, right? So looking outside of those production lines and those production processes for those other wins. So awesome. Thanks so much. So I have another question. So we will keep things moving. I'm wondering, I guess this is like future perfect scenario where you can just, wave a magic wand and eliminate one energy efficiency in the forestry sector. So if you were a forestry energy efficiency magician, Nick, which I think you are, like on your way there, you're almost there. But what would it be? What would your change be? And maybe why would you do it? I'd like to hear
Yeah,
about that.
I think the why matters today. Yeah, I think the first thing I would do is make all mills thermally self-sufficient. And part of the why here is because it's achievable, and it's often the case. It's probably the more common in a lot of a lot of mill types and a lot of areas. But it's not unusual to see substantial gas burn for production heating, when this could be accomplished with hog fuel or other residuals with well-tuned and efficient thermal heating system.
Mm.
The second thing is, just from my observations, going from mills, it would just be to get the woodyard and forestry operations at the energy management table, with mill operations. Um, I don't have a lot of examples to point to because it doesn't happen as too much,
Fair.
but
That's why we need a
I've been
wand.
exactly, that's you asked. And I have been part of enough conversations where it's like, well, if we could do this, if we were getting wood into the mill at this point or consistently, that we'd be better able to manage our drying process, or if you go further back into forestry operations, and just even like in a lumber context, which logs, working with your suppliers in terms of which logs are making it to the yard, so that they don't make it to your chipper. That's the goal. So I think the forestry, going back to the forestry operations and the wood yard, can really help with the debarking and drying process, making that efficient from an energy perspective, but also getting back to that more traditional lean waste, keeping your recovery levels up, and your waste wood down. Ultimately, like, that's good for production, that's good for business, but it's also good for energy. If you're not bringing wood onto the site and partially processing some stuff that's just going to end up as waste.
Excellent. No, great example. So, Nick, I would like you to virtually pass the wand to Shannon. And Shannon, I would like you to wave the wand and solve some energy problems for the sector. What, from your perspective, what would you do? I'd love to hear.
I would work to eliminate equipment underutilization. That gets me going. So does idling of equipment. And there I think is a slide, maybe you could switch to that. It helps to frame an example of this. So this efficiency through intermittency basically is a story about maximizing the use of the equipment you've got installed. And it's based on the premise that it's most efficient to operate equipment at full load. And this is particularly true of equipment with large no loads, or a lot of ancillary or support equipment that draws load in order to operate it. An example that's shown in the diagram here is a refining line. So two parallel refiners. And you have chip feed equipment in these systems that draw load regardless of how much production you're putting through them. And refiners have large no loads, which is of course the load to rotate equipment without production. And finally, most mills have downstream storage, and the use of this equipment and storage, is predicated on the capacity of the equipment and the availability of the storage. One thing to think about if you're thinking about your facility and you have maybe some large no load equipment, but you don't have any storage, it could be an opportunity for you to justify storage. You can save energy cost through time of day operation, but you can also save energy through efficiency. And that's what the table is meant to show here. there's a couple of scenarios. I won't go through it in detail, but on the left, this is an example of how much energy you'd require if you ran one refiner and idled the other, which is a terrible decision unless unless you are imminently starting that refiner back up. From an energy perspective. And then on the far right is an example of when you operate your equipment at full load, but intermittently. So to meet your product or your customer requirements, you operate at full load until your storage is full, and then cease operation. It's the most energy efficient option in this particular arrangement. Gives you a lot of opportunity to centerline your equipment as well. There's a ton of benefits. It's like a set it and forget it. You turn it on, you turn it off, you centerline it at the one production rate it's designed to operate at, which also can open up maintenance windows for you to do maintenance during the day, because often you would, if you're looking at power pool price or different types of price signals in your transmission, your delivered price of power, you would want to run in the off peak. So that would be nights. So this is a huge opportunity, and you can see it also in generating assets. The most efficient way to operate a generating asset, especially if you're paying for maintenance on an hourly basis, is at full load. So that's a specific example, Amanda, of what we can do. Yeah.
I love this very illustrative example, and yeah, I really appreciate also you putting it together in such a way that we can really see the two different kind of examples, and one where it's like do not do versus like much more efficient. So yeah, excellent. And if anyone has any questions, I would just want to kind of mention here, don't hesitate to ask for more detail, or if there's anything you don't understand, please do type that in the chat, because we can address that during the session or during the Q&A after. We can always come back to slides and come back to topics and things as well. So just putting that out there. Thank you both for your wizard skills at this one. So another question. Can you share, and maybe we'll start with Nick again, can you share an example where a small or overlooked change led to significant energy savings? So something that was maybe not obvious, and resulted in a big saving. I think people like these stories a lot, yeah, if they can repeat them, especially.
Yeah, absolutely. So I would start with, set points, rules, SOPs, and recipes, or, any other name you would give to these. They're common practices at mills. But I think they are historically overlooked. They sound boring, for one thing. But the, some small changes, doable changes that can result in significant savings. And some of the most significant changes, and I'm thinking of an example I saw where an OSB mill reduced their gas consumption by nearly half, cut in half. And it was not about redeveloping their rules for how they operate their drying process. It was about identifying their periods of best practice, or their best operator, with this in mind. They haven't looked at efficiency before, but when they looked at the data, they could see differences and trends between shifts, between operators, and interviewed these operators and found the operator that liked, and the way they were eliminating gas is by greater reliance on hog fuel, on their biomass. So I identified an operator that preferred to operate with more biomass, and was what's the word, stringent in his use of gas, as supplementing only as needed. And it was and through identifying that and communicating that practice, all they needed to do was like build that out across their operators, and realized huge, in this case, like $1 million per year kind of savings. So I think that is a great example of small, unsexy, talking just about, setting new rules and standards for how to operate your equipment that can result in big savings.
I love that example, and it's like you talked about it being kind of data driven as well. Like it took them kind of maybe looking at the data, who was operating hours and energy consumption to be able to identify that. Like it would have gone overlooked maybe otherwise if they weren't looking at that. So kind of tying it back to that opportunity to utilize data in order to find those sometimes hidden opportunities, and then standardizing that through the SOPs that you mentioned, right? And making that kind of process for all the operators. That's a great example. Thank you.
Yeah, and you're reminding me, and I'll go further. Just if you think back to the slide you used in terms of that Venn diagram of, you relying on data, but also investigating what's going on the floor and getting input from your employees. It's a perfect example of that because the implementation is maybe not as smooth as I suggested there. There was times when the operators thought they were getting in trouble.
Yeah.
And why are you asking? So they had to be a bit iterative in terms of those conversations and just explain where they're coming from and what the intention was, and that even the operator that was doing the good job at some point thought that he was in trouble for doing things wrong or something. So there's a
Yeah.
whole kind of change management and like making sure to onboard these operators and make them part of the solution and get that right mindset. So there's a little iteration, a couple takes to get it right. And yeah, it absolutely required the data that you mentioned for looking at how this actually is controlled currently on the ground and getting the people that are in charge of that control on board and engaged.
Excellent. No, that's a perfect example. So Shannon, same question for you. Any kind of example of overlooked change that led to big savings from your experience?
Yeah, the thing that comes to mind for me is insulation. It's often overlooked. It's so valuable in keeping the hot where the hot should be and the cold where the cold should be. And an example of this, and I've seen, is insulating steaming bins. It solves two problems. One is the very hot and uncomfortable environment that they create in the mill. Folks don't like to work around them, but it also reduces steam consumption in your process, which is a huge win. And back to the chilled water, you spend a lot of electricity to chill water. Let's keep the cold in the lines by insulating them, and you get the side benefit of not having those sweaty lines, all over your mill, dropping water on your head. And the last one is, if you ever see a line that's heat traced and it doesn't have insulation on it, it should trigger some questions, because insulation vastly improves the efficiency and effectiveness of line trace, especially outdoors. That's what comes to mind for me. You're on mute.
Andy, you got muted.
Oh, thank you. Yes. I'm sniffling a little bit because I have a bit of a cold, so I'm trying to mute myself when I can to not make too much noise when you're talking. Thanks for letting me know. So, okay, next question. Thank you, Shannon, for that. It's great response. What types of energy waste do you think are most often missed in forestry operations? And maybe we can start here with Shannon, actually. We'll hear from Shannon first on this one. What's often missed from your perspective?
It's sort of, I think I have a theme here today around building envelope, but HVAC in buildings. We forget about these types of systems, which are essential to especially our operations in the winter time when we close the doors. In the winter, we always find out this is the problem. We do it at home too. You don't realize your furnace doesn't work until it's cold outside. But the negative air balance is a real problem, and because it pulls air from all sorts of locations in an uncontrolled fashion throughout your mill, and it pulls air, like for example, from warehouses and other areas where there's no process heat. So you get these complaints about cold warehouses, and there's some simple things that we can do. to alleviate this, the low-hanging fruit here is to do an envelope air balance in the wintertime and to do things like close holes in our enclosure, gaping holes or gaps in the building. But also perhaps it's as simple as turning off excess exhaust fans in the wintertime. So having a winter and a summer mode for our buildings. The other is insulation. So if you have high heating load and your buildings are still cold, what can you do to improve the insulated value of the enclosure? And it's expensive to do, but we can do this kind of stuff, in phases, like when you replace the roof, build in insulation in that work scope. So that's a key one, especially when we're talking about retrofitting or upgrading older facilities. Some of us are operating mills in 100-year-old buildings, right? So the other is when you start to see very high natural gas space heating, especially in those warehouses and so on, where you've robbed or stripped all the heat through negative air balance. We should start thinking about waste heat. Waste heat is pretty cheap. You can use it as an alternative heat source to supplement heat and glycol circulation systems if you have central circulation systems. And heat exchangers can range in cost, but some of them can be quite effective, very, very cost-effective solutions for heating problems.
Great. Thank you, Shannon, for those examples that are also kind of tackling that original challenge you were talking about with some of those older facilities and older operations and ways to maybe to work on making those spaces more efficient. Excellent. And I guess same question for you, Nick. Where you think are the kind of biggest opportunities in the sector you have those expertise in?
Yeah, you bet. Yeah, thinking of panel production, these mills move a lot of air around, and I in my experience, I feel like that's not as well understood or appreciated as it should be in terms of where to look for opportunity. And at a system level, I wouldn't claim to have expertise on this, but I've seen enough successful projects to suggest to anyone that they should be looking at this. So, I think most mills are using more energy than needed to move air around and their facilities, whether that's, dust collection or exhaust, drying process itself. And I've seen some successful projects where, an example of streamlining a dust collection where it involved removing tertiary cyclones. And this reduced the system friction such that they could significantly reduce the load on the dryer ID fans. And so I don't think it started as an energy efficiency project. It was more like removing unnecessary equipment, reducing maintenance, and then realizing that the dampers on these fans were just nearly shut and were vibrating and blowing bearings and whatnot. And so it was a huge, these are big fans and easy pickings for savings. We could have put a VFD on there. In the end, we just reshipped those fans and saw significant savings. I've seen similar but different projects implemented where they streamline the exhaust systems to divert entire sections divert and remove entire sections of fans from a flatline dryer system. And both of these projects, I would say, were really led by and required mill systems knowledge, more so than energy efficiency expertise. When we go back to that Menti question around how are you identifying opportunities, data, equipment data, and scans, I think both of these could fall under a category that's like identified in-house by the mill. It could be caught by an energy audit, but would require, I think, someone with a real understanding of fan systems and specific fan systems of your type of operation. Another area, sorry, that's kind of speaking to panels. Switching to lumber, and based on one of our Menti questions, I'm not sure how many lumber mills we got on here, but I don't want to assume we don't have any. So I think what's really important at lumber mills, where a couple of things. These are lower energy consumers compared to the other forestry operations we're talking about, and more commonality from one mill to another, and there are mom and pop, if that's a fair characterization, mills, but a lot are like owned by larger companies. So I think having, let's call it a systematic approach that really just kind of almost on a punch card is like, have we done the lighting? Have we done the compressed air? And have we addressed idling? Shannon's magic wand opportunity. That's what I'd be doing in my sawmills. After that, and what I also wouldn't ignore are the kilns. And that's, I think, what I would point out here is gets a little more, Shannon talked earlier about production versus the non-production system. So the lighting, the compressed air, that's kind of dealing with your ancillary equipment, and so it's less sensitive. Kilns are getting into some more sensitive equipment and sensitive operations within a lumber mill. But I asked a colleague of mine who has a little more experience in this, is like, what would you tell people? And his response is that what shouldn't be sensitive or controversial is just keeping your kilns in good working order. And that means like in good working order and good repair. So that's the structure, your doors and seals, making sure you don't have any holes or gaps in the walls, and the roof has a protective coating to prevent vapor transmission. There's the kiln fan maintenance, making sure like the baffles, the cowling are in good repair, and air passageways are not obstructed. Fans are properly mounted, so that you've got good continuous airflow for maximum efficiency. And then last, getting into like controls, which is where you maybe get more sensitive, but again, it's just the practical kind of maintenance approach to your controls, sensors that are properly connected and protected. Sensors, especially temperature sensors, properly located to make sure you're getting representative readings. Replacing your wet bulb wick regularly. I can admit, I'm not too familiar with that, but he said it and I believe him. Yeah, and just, this is just all about keeping airflow and temperatures optimized, and can realize a lot of savings. Oh, and lastly, he said, that all of this, it's a lot of things, and there's more. And it just underscores the importance of having a continuous kiln maintenance plan. And again, this is piggybacking on and going back to my original comment around these your operations, they're running really lean in terms of resources. So if you had a continuous kiln energy efficiency plan, it might get disregarded, but hence, we're calling it, and it's a maintenance plan. So you're piggybacking on other mill priorities. All of these maintenance items, though, have energy benefits to them. So there's a real synergy there.
Yeah, we hear that a lot from energy managers talking about how they need to piggyback on other priorities in order to kind of get folks to care about this sometimes, right? Like get those people who can release resources and get more staff on things and things like that, that you kind of have to piggyback with either the maintenance, because nobody wants downtime, or health and safety, or whatever it might be, to sort of leverage those opportunities a little bit more with the powers that be, so to speak. So yeah, great examples, Nick, and a very detailed look at those various systems. So thank you for that. So we will start with Shannon maybe for this one, I think. Shannon, I'd like to know, how do you sort of typically go about identifying energy inefficiencies, or maybe more specifically, low-hanging fruit? We talked about kind of some folks here are still in that low-hanging fruit stage of their identification or their project work, not so much yet in some of those bigger projects. So are there any tools or approaches that work particularly well for identifying even more low-hanging fruit for folks? I'd love to hear from you about that.
Yes, I have a couple of strategies I can share there. I think I've said this already, but we're in the business of making forestry products. So one of the easiest ways to move forward projects that are energy efficiency projects is to align them with operational issues that exist. Then it becomes an easy win and people can get behind it. A great way to start is asking yourself or the leadership team at the facility you work at is what are the biggest problems that need solving? There's some examples I've given today. I've heard before, the warehouse is too cold. We're having dryer fires. We have equipment reliability issues, maybe. I've heard more than one time, energy cost is a serious problem for our facility. So these are the easy ways to sort of root out some of the problems that need solving that might have an energy component to them. The next thing I would recommend, of course, is to use the experience and the knowledge already at your facility and go into the field with these people. Go hand in hand with your maintenance and your reliability team, your operations teams, to observe firsthand the problems that they have. And I have an example here of a time that occurred. I think it's the next slide. Thank you. So centrifugal pumping, near and dear to all of us who move water in the pulp and paper industry. We have tons of pumping. In this particular case, hearing at the morning meeting over and over, we have chronic loss of packing on the power ends of this set of pumps. There were 2 lines, an A line and a B line, and each time a power end needed to be repacked, it caused a process bottleneck. So production was impacted. So went out into the field with a whole bunch of folks and found out operations was discharge throttling these pumps significantly. So the valves on the discharge side of the pumps were only 30% or less open. The electrical folks had checked the motor load just to confirm the operation of these pumps to find out that they were operating at a fraction of their full load amps, which means they're not really moving water. Engineering, when you check with them, they always pull the pump curve out, and it becomes clear in a hurry that these types of pumps don't operate well at deadhead pressure, and that's where they were operating. And then the mechanical team can tell you things like maybe the equipment's running hot, and you can feel that in the field. And a real telltale sign is to look at the discharge pressure gauge. And if the pressure gauge is highly variable, you have some cavitation in this pump. It's easy to conclude in this particular case that the pumps were oversized. And this is a group effort to get to this point. So what can we do about it? That's the next slide, Amanda. Yeah, so this is a nice pictorial description of the system I'm talking about. It was 2 large cleaner feed pumps with discharge throttled valves to meet a pressure set point. And they actually had a crossover line with an isolation valve. So there were quite a few configuration options. So looking at the curves, you find out that you can actually operate one pump to feed both lines. Made this change and tried it out, found out the pumps ran better. The reliability issue was resolved. Now the mill has an inline spare. You can do maintenance on the fly, and energy consumption was decreased. So this is how you can couple sort of solving the problem with the energy efficiency opportunity. Another example that comes to mind that I've seen work in facilities is spending time to reframe electricity or energy specifically as a key input that can be actively managed. In some cases, we are focused so heavily on the production line, we forget about what it takes to make it run. And a tool that you can use is shown on the slide here, which is putting together a real-time single line diagram. So often we talk about the work electricians do as a black art, and the single line diagram is owned by these folks. But putting together a single line diagram, it can sound intimidating, but it doesn't really need to be. What this is really just a flow diagram that shows where electricity goes in your mill. And maybe you've already spent the time to identify all your significant energy users. This is a really effective way to educate your operations team and your technical teams about how energy is used and how it's distributed, where your metering is or isn't. It highlights those gaps. It can also help you if you're operating a facility with generation and load balancing, especially in those situations where you want to drop load to export electricity, let's say at high price. And this really just allows you, it's a tool that educates energy teams and energy champions and operators and all sorts of people in the mill, management included, that about electricity. You can do the same for natural gas as a fuel distribution diagram, and it becomes something that can be actively managed. That's a way to find some low-hanging fruit. That was
Thank you.
yes, that was it for me. That's quite a bit though.
No, it is. Thank you, Shannon. And I just want to check, can you all hear me? I was having a, I'm not sure if Shannon was just cutting out for me and it might be my connection. So I just want to make sure, can everyone hear me okay?
Yep, you're clear.
Okay, great. I just turned off my camera because I want to be cautious that I don't lose that connection, but maybe we're okay now and I can try it on again. Okay, great. So Nick, I think we need to push this question back to you. We're coming back to you with this one, yes?
Yeah, yes. Great. So I agree with everything that Shannon said. There's, particularly or what jives with my response to this question is getting a cross-functional team involved in this. And I'm going to call back to the Menti question around how do you identify opportunities, and one of those that had a decent number of responses was the energy scan, which I don't think we explained for people, like some would be familiar, but this is kind of can be thought of as an alternative to the energy audit that relies more on the in-house knowledge and should involve a cross-functional team going, walking the floor of the mill. So I think that's incredibly important. I answered this question when Amanda asked it of me of like, what do I do? So if I'm leading that energy scan, coming in with outside eyes, and come to site, I never want to show up without having some data beforehand. And in this approach, I would say, always start with just the readily available data. I don't mean to be onerous asking for data that doesn't exist or doesn't, would need to go out and collect it. It's just what is available. But the reason I do this is that I feel like this data provides us with, if no one's looking at the data currently, at least, it provides us with the best opportunity to find something that's going to make, a group around a table say, oh, that looks strange, or that's not right, because you can see this data. This is giving a different perspective to something that you can't see on the floor. So when I go in and do an energy scan, like I'm pulling their knowledge even into the boardroom of like they work, or you all work on these sites day in, day out, so you can picture these things. And yes, we'll go and walk the floor and gain some value of that as well. But the data is bringing a new perspective to it. So I think that is the first thing that I would do to identify low-hanging fruit. The other thing that I would say that we've kind of touched on a few times as well is, is looking for waste. We talked about the 9 energy waste, but you can also listen for waste, and this goes back to Amanda's point that if it's noisy, it's lossy. So vibrating equipment or just equipment that's known, and this goes back to Shannon's point of like, what are the biggest problems? Where are your problems? And because there's usually an intersection with efficiency. The one thing I'll say about all that is that when you go out and you can see on the floor, say, leaks and such, these are probably known issues, and the reason they're not being addressed, it goes back to right off the top. They're just maybe not a priority, and so that yeah, I don't mean to be a downer on that, but I guess it just is making that point again of like, we got to tie this to some priority or other benefits other than just the energy savings. The last thing I'll leave, sorry, an example of building on other priorities. And this is just a recent one that I thought was interesting and kind of got me unexpected in that, VFDs are often you could consider them to be an almost overused energy efficiency solution or a crutch. They're put in situations where, like Shannon's pumping example, where you could just run one pump, or where really the right solution might be to downsize that pump rather than putting a VFD on it. But when VFDs have been the right solution, I've historically seen some hesitancy or reluctance from operations, not just because of the upfront cost, but just, the operation of the drive itself, introducing that into the mill controls and operations. But I've seen, and I can't say that this is true across the board, but the example I wanted to raise just kind of flipped that script where, this operation was keen to use energy efficiency to justify getting more drives in because they wanted the drives. They wanted the drives for better, more precise control to improve product quality or just production optimization. And so I had to check my previous assumptions on that. And I need more of a sample set to see, whether most of industry is at that point in terms of the adoption of VFDs. But that was an interesting one for me to observe, to be like, oh, okay, this is something I can now put as a way to sell VFDs as opposed to a hindrance to their adoption is just an energy efficiency measure.
Excellent. No, thanks, Nick. That's great information. I just want to do a quick little time check because I do want to make sure that we have time for questions. We do have some more questions for Nick and Shannon, so I'm not necessarily going to skip those, but I'm checking in the Q&A, and I don't see any questions coming through yet. So I'm going to just kind of pause for a second and ask that if folks have burning questions, either about what has been discussed here or new things we haven't touched on yet, please utilize either the chat or the Q&A. I want to make sure we hear from you, but I'm going to keep going with Nick and Shannon if we don't hear anything. So just if you do have the questions, get them in there because we really want to make sure that we get them answered for you today. So in the meantime, I have another question I'm going to go to Shannon for this one. Nick was talking quite a bit there about data and using data to find those low-hanging fruit. I want to know, Shannon, what kinds of data or signals are you paying attention to when you're making energy-saving decisions?
Yeah, data is, I'm a supporter of data-based approaches. So all data has value. One of the things I focus particularly on, as a person who's worked in operating facilities for many years, is production. Energy efficiency, the numerator is how much electricity you use, the denominator is how much you produce. Lots of the greenhouse gas and carbon programs are based on intensity. So increasing your production per unit of electricity, especially spreading baseload amongst more tons, is important. So I ask the question whenever I see a piece of equipment, like I've talked about already, is how much can this piece of equipment produce? Are we at that capacity? Or can we shut down one line and operate another at marginally higher energy consumption on that line to serve the entire load? And we can see this in water applications quite a bit, where you have parallel pumping lines, for example. The example of refining is a good one as well. Another one I think that's really important is when you're thinking about energy efficiency projects, you can think of them two ways. One is to produce the same amount of production at a reduced energy consumption, or the other is if energy is a bottleneck, is how can I produce more product at the same energy load? And we see this when people optimize things like dryers in the OSB field. If you take a dryer and it's your process bottleneck and you make it more energy efficient, you can produce more product. So I guess my answer is production.
Excellent. Looking for those indicators coming out of the production numbers and consumption and things like that. Excellent. Thanks, Shannon. And Nick, you got a little bit into data, but I want to hear more. What kind of data? What's important for folks to be looking at when it comes to their data and their indicators or signals?
Yeah, you bet. And this is absolutely building on what I was just talking about in the last question. And I took this question a little bit differently and to say what to do with data. And my point being is when looking at energy data and energy data trends, I'd say visuals are essential. This is probably true of all data, in fact. But we're going to have a difficulty gleaning anything from numbers in a table or something even less organized than a table. So creating the right visuals can really help identify trends or abnormalities that might indicate energy waste or periods of best performance, like the example I was using before. So this could involve, simple raw data and just plotting it across on a time series and seeing what's up, what's down, and why. And you got to be able to ask those questions and peel it back. Where this could get more sophisticated is normalizing the data, and this kind of gets into part of Shannon's answer of like looking at how we know that energy and production are going to be related. So can we normalize for production and in order to isolate and see what else is impacting our energy consumption? And in whether it's normalizing or just making sure we're comparing apples to apples. So periods of comparable operation I think can also be useful. I've seen a lot of energy reporting where they're explaining, they're just using energy intensity, or a company might be using energy intensity. It's part of a reporting metric, a KPI, and it's high, and that's bad. And so they're explaining why, and it's it's because production was low, and then it's good the next period, and they'll take credit for that for all sorts of reasons. But in either case, it could just be not properly normalizing for production. It's an intensity based equation versus accounting for the base load that's a part of your operation. So if you don't account for that base load, yeah, low production is not going to look good on an intensity basis because of that idling equipment that Shannon's mentioned, and higher production, you're going to get efficiencies of scale and see better efficiency, but that data is not working for you. You're just kind of explaining the results in a backwards kind of way. Amanda, you still with us?
Thank you,
okay.
Nick. And I just want to check that y'all can hear me because
yeah,
can you hear me there, Nick?
Yes, absolutely.
So everyone, you got me?
Yeah.
Oh, okay. Great. Okay, I think you're on your end. I'm getting some interference, but that's okay. So next question for you both, and maybe we can start with Shannon. Is there a common mistake or misstep you've experienced that others might benefit from learning about? And yeah, we can maybe go to Shannon first for that one.
Sure, I've made many mistakes. I think one of the ones around energy that comes to mind for me is, initially I thought looking at the largest loads would essentially be the silver bullet, and I went into it with the mindset that just the potential energy savings on that piece of equipment would be motivation enough to drive change. Like, this is an exciting opportunity to reduce energy. How come everybody doesn't see it that way? There's lots of reasons why that doesn't work. And I've talked about some of them today, but what instead I've moved to is more of a systems-based approach. So systems being, all your HVAC or your entire refining plant or your bleaching plant or what have you, so that you can look at the total impact and how you operate it holistically, and then thinking as well about the motivation for change. It has to be for multiple reasons, and it has to fix a problem. So that's how it's changed. And one example I think I have here, there's a slide that this is a super pulp and paper like intensive example, but stick with me here. This is a really important one. Anyone who's worked in a pulp mill or a paper mill with cleaners knows that they use a ton of electricity. They're thin stock based, and operators don't like them. They're a headache. They plug all of the time. So there's lots of motivation to use less of them. My previous example about the 2 lines and shutting one pump down is actually part of this system. And so the question then was raised after you shut one of the primary feed pumps down is, do you even need the 2 lines of cleaning? It's so energy intensive. Can we just make do with one? And what is the opportunity to move to a lower energy technology like screening, which isn't as labor intensive or problematic for operators? And then finally, once you land on a different technology, can you repurpose the equipment you have to achieve the same result, like only cleaning your reject streams off your cleaners, for example? And this is an example of a systems approach where you could narrow in on just 2 pumps, but what you really need to look at is the 1700 and or so RPM or 1800 RPM. Sorry, yeah, horsepower that's part of this whole system. So the opportunity is quite a bit larger, as is the problem that you're trying to solve for operations.
Excellent. Another great illustrative example, Shannon. And I think this speaks to Nick's point about like the importance of illustrating data and actually seeing things and being able to like show people what's happening. And I think you've put some really great examples of how that could be used to show folks what's happening and show folks other opportunities. So I really appreciate the effort you put into some of these illustrative examples. And
Thank
Nick,
you.
we're gonna kind of consolidate as Shannon did a couple of our last questions around, sort of mistakes you've made that you can learn from, and maybe that have resulted in you taking a different approach to the way that you do things or that you approach things. So maybe we can kind of wrap things up here with your final thoughts on this, and then we'll check in maybe if there's one or two questions we might have got something, but we can wrap things up here on time. So yeah, I'll let you go ahead, Nick.
That sounds great. At first, I wanted to call out myself based on what you're saying of Shannon's great visual here. Just realized, and I just talked about the importance of visualizing data and didn't even have a slide to visualize that while talking about it. So that's on me. But backing up to and combining these questions. So, oh, sorry, I got a little lost in my notes there. I'm going to go kind of if Shannon's talking about the whole systems approach, which I love, and then my example of a common mistake that I've seen as well as made that could be applied to a system, but even when you're just getting down to the equipment level, and maybe you are looking at a VFD solution, and I've just seen a lot of wrong assumptions about what the current energy consumption is, like what the baseline is, or what the flow rate is, or you're going to reduce that flow rate down to after installing a VFD. So my advice is to put in the extra time to take those flow measurements on pump and fan systems, for example. Compressed air would be another example where this flow information, if you want to accurately estimate your energy savings before making an investment, those measurements are just absolutely crucial. And then in terms of how is that informed my approach. Let me see if I can stitch these two together. I don't know that I can really segue, but there is a
It's
callback
tough.
to
I gave you a challenge
yeah,
here.
there is a callback to a theme, and something I pointed out right at the beginning here is that identifying opportunities is great, but it's really just, and this is something that's changed for me over time, is like this used like when I was new in this industry, this is just what got me jazzed. It's just identifying the energy waste. The more time I've spent working in the industries, I've seen so many great opportunities that don't turn into results. And so the reality is that just identifying these opportunities is maybe the tip of the spear, or just part of an overall energy management system. And that we need the other elements such as management commitment, a functional energy team, you need organized planning, you need operational integration, you need the monitoring and reporting to get this data and these insights to actually turn these opportunities into results. So that would be what's changed for me. I'll leave it there.
Thank you, Nick. We did actually get a few questions at the 11th hour, and we do have only 5 minutes to wrap up, but I want to kind of, maybe we can kind of reiterate some of what might have already been said, because I think potentially we talked about it a little bit. But one of the questions was, what are the most cost-effective energy-saving technologies currently being adopted in the forestry sector? So more like cost-effective, maybe not a lot of financial resources to approach some of these projects. And then the other question we had was some examples of successful energy transition strategies from traditional to sustainable practices, which I think is a pretty broad question. So I don't know if either of you kind of want to tackle one, or maybe referencing some of what was already discussed to talk about what areas of what we discussed are cost effective, or maybe a more traditional to sustainable practice transition.
I'll jump in on the first one first.
Sure.
It's probably the easier to answer because, as you said, the second question fairly broad. But I think when you're looking for cost-effective solutions, so I'm going to assume you're talking about, well, I'm going to like no cost. I think we've talked at some length on like there are lots of operational low cost kind of like no capital cost, like operational cost opportunities in forestry. But if we're talking about actually like some capital projects here, I think what's really useful is to look at your most expensive energy. And Shannon mentioned this in terms of chilling water. We spend a lot of money to chill water, for example. The other one that's classic is compressed air. It's by far the most inefficient utility. Even when you think of it in terms of the compressed air, it takes so much relative energy, like the electrical energy, to create the same amount of compressed air energy. So if you're looking for a high rate of return, compressed air is always a good place to start.
Excellent.
Yeah.
And do you have anything to add, Jenny? Yeah, we have you. If you have maybe a minute or so
Sure.
of a response, no pressure.
No problem. Yeah, for the sustainability thing, I think in the forestry industry, it's really it's uniquely positioned in that regard to move away from fossil fuels using biomass or biogas or biofuels of any sort. I think that's where the focus needs to be. Again, capital intensive. But as you know, price of fuels and carbon tax, depending on where that goes, I guess, increases the driver towards using renewables for our energy supply, especially in drying applications and in electricity generation. I think that's where we're going. I hope it'll help. It'll help with the ultimately with the future and the sustainability of our industry financially as well as environmentally.
Amazing. Well, I think that's a really good place to close off the conversation part of this. I just want to say thanks so much, Shannon and Nick, for all your work putting together these insights to share with everyone. And this will be available as a recorded version on YouTube. So if you haven't caught everything, because I know sometimes we were moving quite quickly through the conversation, you will be able to go back and listen again and catch some more. more. I did want to note we didn't have lots of questions come through, and that's okay. There is an opportunity as part of the Energy Manager community, if you so are interested and you are not already part of that, to ask questions on things like our discussion forum that we have as part of the Energy Manager learning platform. So anything where if you were maybe biting your tongue on your questions, getting involved in this Energy Manager community and being able to kind of crowdsource some of your challenges there can be super helpful. There's free expert support on improving energy management practices and energy efficiency projects in all different sectors, forestry and beyond. So it's a great place to get involved and get more information and really improve your operations. I also I believe Finnan is going to drop a resource in the chat. It's a little slide that has direct links that you can click on to get sort of the post-webinar support intake form for tailored support for organizations to manage energy resources effectively. You can sign up for the monthly bulletin if you're not already receiving it, with lots of training updates on different things that are coming up down the pipeline. Also, a link to the live training calendar and the training and support webpage for you to check out. And just a note, if you are on the mailing list already, if you haven't already got it, there will be a survey coming out, and please do fill it out. It's not spam. It's a real important survey to give feedback on sort of the program and the trainings that you're doing and how you're getting involved. So we would love to hear feedback on that. And we are 1 minute over time, so I'm really sorry that I kept you a little bit longer. You know, if you have time and you want to jump onto the Menti and let us know if there's anything that inspired you about this session today, and something that you heard that you would like to implement in the next week to start capturing more energy savings in your forestry operations, do feel free to use the Menti and add it in there, because we'd love to hear about what you're going to be doing next. So thank you very much. Thank you to David for joining us for the session, and Shannon and Nick, and of course to Finnan as always. And thanks to all of you for coming and listening to us. And we hope that you got some good information today. So see you next time, and have a great rest of your day and your week. Bye-bye.
Thanks, everyone.
Thank you.
Great day.
Excellent.